Here is the problem to find radius of convergence of the given power series. So you guys notice there is x in the series terms. So let's write down the term. An is n divided by 5n times x to the power n. Let's use ratio test to check if it's convergent or not. So I'm going to write an plus 1 is n plus 1 divided by 5 to the power n plus 1 times x to the power n plus 1. So I wrote that. I've put ratio test for here for your reference if you forgot. So I'm trying to find the limit L. Limit L is limit n approaches to infinity an plus 1 by an in absolute value. Let's find that. We've wrote an plus 1. That is, what is an plus 1? This expression, n plus 1 divided by 5n plus 1 times xn plus 1. And an is this, n divided by 5 power n times x to the power n. Let's write it one more time. Limit n approaches to infinity. Everything here, all the terms are positive. So let's assume x is also positive, right? Only x we do not know about. All these terms are positive. So these terms can be taken out of absolute value. So the denominator will flip times. You see here we have x the power n plus 1. Here we have x the power n. N factors of x will cancel and only will be left with x. And I'm still keeping x in the absolute value because I don't know x is positive or negative yet, right? Now, you guys notice these 5 n factors of 5. Here, n factors of 5 will cancel. Only one factor will left. So this is basically equal to limit n approaches to infinity 1 by 5 n plus 1 by n times absolute value of x. Limit n approaches to infinity. How are we going to find this limit? Only thing here affected by n is this expression. Everything else actually can be taken out of the limit 1 by 5 times absolute value of x. And here we have n plus 1 by n. We want to find this limit. I think I'm going to divide everywhere by n. 1 by 5 absolute value of x. This is limit n approaches to infinity 1 plus 1 by n by 1. This thing goes to 0. So this whole limit is just 1. When we multiply that, we have only absolute value of x by 5. Okay. Let's go back to the ratio test. The ratio test says if I find this limit is L, right? L came out to be this. If L is less than 1, then only the series is convergent absolutely. So we are going to say the given power series is convergent absolutely if, we don't know, but we are saying if this thing, absolute value of x by 5, is less than 1. What does that mean? When will that be less than 1? When absolute value of x is less than 5, right? So we are not saying the series is always convergent. We are saying the series is convergent only if absolute value of x is less than 5, right? I want you to go back to our convergence theorem, convergence of power series theorem. It says if there is R such that the series convergent absolutely if x minus a is less than R, absolute value of x minus a is less than R. Let's look at this using our example. So in our theorem said R is the radius if series is convergent for this. Now comparing this to this, what does that look like? You can write this x minus 0, absolute value less than. In place of R, what do we have here? 5, right? We know that A is 0 and R is 5 for our series. You guys notice here, if you compare it to, say, x minus a the power n, then A is 0, right? So r is what? 5. So we found radius of convergence. Radius of convergence is 5. R is equal to 5. That is our first answer. The question was to find the radius of convergence where the series is convergent. The next is interval of convergence. So remember, for interval of convergence, for this kind of expression, we said a minus r to a plus r. So what is that? Now it's gonna be interval of convergence for us is equal to negative 5 to 5. How did we get that? You guys notice we had the center at 0 and subtract 5 from 0, we will get negative 5. Add 5 to 0, that will get 5. So a minus r, 0 minus 5, a plus r, 0 plus 5 is 5. So this is our interval of convergence for now. I don't know about when I put negative 5 or 5, what happens at the end points. So I would need to test what happens at the end points. Let's do that. I'm going to write my series one more time. Let's check at x is equal to negative 5 first, right? First, I'm checking at negative 5. So in my series, I'm writing n divided by 5 the power n. In place of x, I am writing negative 5 the power n. So I want to check, does that series converge when x is negative 5 or not, right? So you guys notice 5 the power n and negative 5 the power n will cancel. Only negative 1 the power n left. So this is 1 to infinity n times negative 1 the power n. Now, here the term nth term an becomes n negative 1 the power n. If I take limit of that approaches to infinity, clearly that is not equal to 0. So this series diverges. Similarly, you can check for x is equal to 5, this series will become n by 5n times 5n. This will cancel. So that is just, that also diverges using divergence test. So what did I test with that? Endpoints are not included. So this is our interval of convergence only from negative 5 to 5, because endpoints, at endpoints the series is divergent. So if you do until here, that gives you the open interval. Then you need to always check on the endpoints separately. And we've checked at endpoints, it's divergent in both the cases. So we are not going to use endpoints. We are saying the radius of convergence is 5 and the interval of convergence is negative 5 to 5, open interval.